Hello and welcome to this episode of T-Tech. Today we're going to be building an enterprise network. I do hope you enjoy this one, and let's get into it. Hello and welcome to this episode of T-Tech. So today we're building an enterprise network. So I've went and broken this down into our steps here we're going to take. And the first step we want to take is the network infrastructure. Now the thing with the network infrastructure is that you want to have, based on the different departments in a company, you want to tailor that network infrastructure to what you need. So if you want 3 groups of different departments where you may want them separate, it does not help to only have those 3 groups of departments on one LAN. So one network, in other words. Because the only way we can do the filtering is with having separate networks. So that's what we're trying to do with our infrastructure and segmenting things out. That's the whole purpose, is to help better secure things and break up the broadcast domains so the network performs better and has less latency. So what we have here is very simple, fairly simple anyway. So the first thing we have is a DMZ segment, and that's going to be for any public servers we want on this network. So that's what they will sit in and be protecting. Having that segment allows us to protect the rest of the departments from any attacks on those servers from the internet. So next, of course, we need the office segment, and this is for any kind of HR activities, payroll, anything like that. So you'd want that separate. And, obviously don't want a hacked DMZ server being able to kind of reach over in the HR department. You can see how that could be very bad. You could get information breaches, you could get sensitive information leaving the network. It's not a good thing. So, of course, in most, a hospital, for instance, you need a guest network. You need at least wireless, not so much Ethernet anymore. I mean, my goodness. But you need that so they can come in and still access the internet and access all those resources. But of course, to not muck around with anything else. So that's what the guest segment is going to do, and that's for the public. Now, we do also need a vendor segment, and, depending on the business, the use of the vendor segment just depends on their needs. It could be a vendor coming in, installing network equipment, and they need to be able to access the internet to download patches for the equipment, etc. And, we don't trust them, though, to get into other parts of our network. Now, excuse me. The last one here is our management, or our IT segment. This segment serves to be where we want to monitor the network from. So this would be where we have our NMS, that's the network management system. So this system takes information from things like SNMP, Simple Network Management Protocol, and things like NetFlow or JFlow, and it puts all that information from our devices, whether that be routers, switches, firewalls, servers, what have you, and puts it into nice graphs. So we can analyze those graphs and look for anything abnormal. And as well with SNMP, we can make sure the devices are up and functioning how they should, and be proactive about any problems that may arise. So the IPsec site-to-site VPN tunnel. This is actually not only for connecting branch offices to a headquarters office or another branch office to another branch office, but it is also now that with the cloud, we can have another firewall in the cloud that has a VPN server capability. And when we make that site-to-site connection, our on-premise branch office is connecting to the VPN server in the cloud. And that way, we can access resources in the cloud for our company, but having the VPN allows us to do that over the internet. Now, the reason it's important is that's a lot cheaper than having to have your own dedicated like T1 line for that purpose, as used to be done. It even still is in some cases. But the reason that's important is you may over time want to move servers into the cloud. It's cost effective to do that. And even still, the VPN is a secure way for clients on the LAN to access all those services. Now, speaking of accessing the internet for all of these segments here, you want HA, and HA means high availability. That means your clients will always be able to send their packets to a default gateway. So the default gateway is always going to be able to send traffic towards the internet. So in other words, you always have a layer 3 path. You have layer 3 reachability. So that's important though, because if that goes down, the cloud resources go out because those are on the internet, as well as a lot of the operations inside the premise. You have to think too, a lot of the software we use nowadays is leveraging the cloud. So in there lies your problem, because if the internet goes out in that case, like Office 365 for instance, that's cloud-based. And it syncs to the cloud. But I mean, if you're trying to collaborate with other coworkers and the internet goes out, you're not going to be able to get any work done. So obviously though, for that DMZ, we are also going to put another dedicated firewall in there because we want extra protection. And it'll make more sense just showing you on a diagram. So let's go to the next part, step 2. So network services. This is any server they need in the premise or on the cloud. So the first thing, a dhcp server, that is a dynamic host configuration protocol. And this allows IP addressing and default gateway information and DNS servers, among other things, to be assigned automatically. The next thing is a DNS server, the domain name system. And the reason is you want to have, if it's a big network, you do want to have the equipment with a domain name assigned to it, so it's easier to access. And going back to that NMS, sometimes it's easier to use a domain name in some of that versus the IP. But what you want to do after that is we need to create a web server, because we may have an internal website that employees have to access, for various things, and as well though for the DMZ. So what I want you to get is these servers provide multiple services to the enterprise, and they don't have to be in the DMZ necessarily, depending on what they're doing. Because for instance, you don't have the DHCP server because it's local on the LAN, giving clients on the internet internal IP addresses. That doesn't happen. So, of course, an email server for your company's domain name and their email address. And you can also, you're not just potentially creating these in an enterprise, you could be coming in and replacing these. Same thing up here. You can substitute this with replace. You could take some of these out. So this is a good, somewhat of a guideline. You can add and reduce what you don't need in your plan. So, network documentation. So we've went in and we're designing it. We've taken some time, thought about what we needed, and we needed to make our subnets, address them, do our subnet masking, and all that. So we've done that. So this is what's going on. You know, at the top we have the WAN. Let me get my mouse here. We have the WAN here. We have 2 WAN links. Those are our firewalls. We have 3 core switches. Here is an Ether channel bundle or LAGP bundle, and that means it load balances between the switches, and that it's for increased bandwidth. Here is the firewall there, the second firewall for protecting here, the DMZ. And then, of course, our guest, office, vendor, and IT and management subnet. To the left here are the management IP addresses. But one thing before we talk about the IP addresses, you'll notice in this that you only see about 3 switches, and it doesn't look the same as maybe, what you have seen before. Well, the reason that is, and if you haven't seen this before is why I'm mentioning this, is something called VLANs, and it's a virtual local area network. Now, the reason VLANs help us is they allow us to have more networks share one cable or, one switch. And they also help break up the broadcast traffic, so the groups of computers, the broadcast domains, without having to have separate. Because without this, we have 5 networks. We would need on each firewall up here 5 interfaces. And you need the cabling for that, the switches. And that is quite tricky to manage. It doesn't scale very well. So the VLAN IDs use a protocol called 802.1q, and that allows them to tag at layer 2 those Ethernet frames. It just puts an ID in there, okay? And the ID is just a number between 1 to 4094, at least by default. And these numbers here get at layer 3, like for guest here, the 10.10.20/24 network. Office, the ID of 30 up here. At layer 2, when it frames a packet from that IP subnet, it puts that number on there. Even though it's going across from here, it's going across the same wire, the DMZ and any of these networks can go over, and it's getting tagged. So when it comes up to firewall 1, the VLAN ID and subnet work together to identify that group of computers. Hope that made sense. But with those all together, these are our subnets. For the WAN, we have an external part of our DMZ. That's this interface on firewall 3. We have an internal portion of our DMZ inside of here. And then, of course, our WANs, our firewalls, and then our core switches. And the management IPs are what we use to telnet or SSH into the device, as well as manage it and monitor from, the NMS system. So, excuse me. All right. So with that out of the way, though, that is how our network is going to look. So now what we're going to do is, I didn't explain the reason you have a second firewall is if these firewalls were compromised for some reason, or something else got infected with a worm or something, this interface here, the DMZ external, is going to be the WAN interface in a way, basically. What that means is we're going to block everything coming into that interface, and do port forwards for traffic getting into the DMZ. But go on to now is the DMZ. So we have 4 servers here, and what I do is we have S1 for server 1. Its service is web. The operating system we're going to install on that server is Debian Linux 10, at least at the time of this recording. The architecture of the server is AMD 64. The server software we're going to use is Apache. You can also use Nginx, does not matter. The IP address of the server is 10.10.5.251/24, and the gateway is 10.10.5.1/24. And once we set up our DNS server, we could, of course, put that information in there as well, or an external DNS server. Don't worry about that too much. Server 2, same thing, but it's a mail server, and everything is the same except it is using iRedMail for the SMTP and IMAP services, and the IP address. Do see the last octet of that IP is the same as server 2, it's 252, so it's easier to keep track of. Server 3 is our DNS, and likewise its config, and server 4. Now, server 4 doesn't actually have to be in the DMZ. It can be, but it's not necessary. We could also put that in the office. But there's something very important. If we want DHCP pools or scopes for all these networks, we need to create a relay agent for DHCP. And on these firewalls up here, what we would do for these 4 is create a relay agent. So when the IT or vendor network or guest sends a discover message out for the DHCP discover message, the firewall up here would take that broadcast, turn it into a unicast, and then send it back down to the office, and then the office would send it back up. And then it would get that packet across the broadcast domains and still get the IP addressing information from that server. That way you don't have to have a DHCP server in each network. You can have one with every scope on it and have that relay help every network get to it. A lot of information, I know, but that is our main setup, all right? So in the next portions, we're going to go ahead and set some of it up, from the network infrastructure to the server stuff. All right, welcome back. So we're starting here on firewalls 1 and 2. And what we're going to do is take all those addresses and we're going to configure the interfaces for all that to happen. So the VLANs, the FHRP for the redundancy, and all of that. And, in addition, the WANs as well. So what we're going to do is this here. We're going to start on firewall 1. And if we run ifconfig em0, this one interface is what I'm going to basically take here and make it into multiple LANs. So when I make VLANs, I'm taking one physical interface and one physical cable, okay? And I'm having multiple layer 3 networks use that cable, but because of the VLAN ID, they are logically separate on one cable. Without VLANs, when you use a flat network, you can't logically separate IP networks like that. So you have to physically separate them. So when it's a flat network, you have to have another cable for each network. So in this case, we have, let's see, 1, 2, 3, 4, 5 networks. We'd have to have 5 separate cables, 5 separate switches, 5 separate interfaces. So that's why VLANs are so nice to use in this scenario. So anyway, we're going to start with vi, and we're going to go into etc hostname.em0. And all we have to do is bring this interface up, and that's all we have to do, because all it has to do is get frames. It's not actually doing any IP routing. So then we're going to go in to make a new interface. So VLAN 10 here. And we're going to start and look at our diagram for 10 here. Actually, I'm sorry, it wasn't 10 yet. Let's actually start on 20. Sorry about that. So for 20. And what I've done is the VLAN ID number is the third octet of each IP subnet. So VLAN 20 is the guest, so 10.10.20/24. So init 10.10.22/24. And then for that, we're going to then have VNet ID of 20, and then we're going to have parent EM0. Now, when you're bringing these interfaces up, you have to specify the broadcast address of the subnet. Otherwise, you'll get an error. So the VLANs are going to look very similar and repetitive, but it's important not to mess this up. You could get subnets that are on the wrong VLAN and introduce security issues. The init, the IP address here, that's the management address. So basically, it's the real address of the interface. And then you have the subnet mask. And after the subnet mask, you have the broadcast address. VNet ID, this is part of the 802.1q protocol. This is saying if you send frames out of this interface, tag them with VLAN ID 20. And if you receive frames, they should only have the VLAN ID of 20. Otherwise, discard them. And parent means the physical interface you're receiving the frames on, because otherwise it wouldn't be able to actually send onto the network. So we're going to just hold shift there and tap the Z key twice, or just colon and then type WQ. Either one works. So that was our first VLAN interface. Let's up arrow, make 30. Now it's very fairly straightforward. 10.10.30.2 on firewall 1 anyway. And then of course that broadcast. And then of course VNet ID and then EM0. And 40 here. And VNet ID of 40 and parent of EM0. And 100. 10.10.102. Right, and then for the DMZ external, that is, let's see, VLAN 10. So we got one more to do. So VLAN 10 there. All right, a quick way to verify it, at least on if you're using OpenBSD or, stock Linux and you're using the CLI to do all of it, do ls and then use the etc directory and pipe that to grep. And then what you want to look for is VLAN. And then we can go through. We have 10, we have 100, 20, 30, and 40. So let's compare here. 10, 20, 30, 40, and 100. Good. Now the DMZ external will be on the other side of firewall 3, and that one won't be VLANs. So we don't have to worry about putting that VLAN in these firewalls. Alright, so we have the VLANs, but now the VLANs, we want to add redundancy to them, and we want to add that virtual IP. So if I show you here, we added on firewall 1 the .2. We want to go through now and add the .1, the .1 that is served by the CARP protocol. We want to add that to the VLANs 10, 20, 30, 40, and 100. So to do that, we want to now make what's called CARP interfaces. So we're going to start with CARP 10, and it's going to be somewhat similar. So the subnet is 10, 10, 10, but now it is .1. Remember, this is going to be managed by CARP. Because of this, either firewall 1 will respond at this address, or firewall 2 will respond at this address. And we're doing an active standby configuration, so only one will respond at a time. And CARP sends advertisements, and that allows the firewalls to know which one should be responding at that time. And the process is, if the advertisements aren't seen on firewall 2 in this case, firewall 2 will take over that virtual IP. And because of that, you always have a layer 3 path. So in the guest, in the vendor, in IT management or office, if firewall 1 goes down, even for a specific VLAN, because these instances are independent of each other, you could have firewall 1 having to send, traffic for VLAN 20 over to firewall 2. But because their VLANs and the CARP is independent, you could have failure of a specific one and still handle traffic for the others. So it could be split across the firewalls. But that's one way to do it anyway. So after that, again, we want to add in the subnet mask, and then we want to add the broadcast. So here we want to add the group ID. So this is a virtual host identifier, or VHID. This is 10 in this case. So let's see, yes, and it's matching the VLAN. And then we want to add a password with pass test in this case. Of course, use a stronger one. And the CARP dev, we're going to match this up with VLAN 10. So this is where it's receiving packets on, and it will send those CARP advertisements off on this LAN, off that interface. So because of that, the advertisements themselves will get tagged with VLAN 10 and only be heard on that VLAN. So let's go up to the guest one here, 10.10.20.1 with that broadcast. I'm sorry, that's subnet mask. Okay, VHID 20, passive test, CARP dev of VLAN 20. Let's move to 30. Oops, pass test there, and CARP dev VLAN 30. Now, when we get to the second firewall, we will change what we're doing in this file slightly. Let's see, that was 40, right? Yeah, that was 40. Okay. Okay, and then that mask, and then we want to do the broadcast address. Okay, and then we're going to do CARP dev VLAN 40. Now the last one here, we want to do 100. And VHID of 100. Password of test. Carpdev of VLAN 100. Now, those do have the password has to match, as well as the VHID. So, if those two didn't match, or the carpdev was wrong for an instance on the other firewall, the instances won't work correctly. Okay, now to verify again, we're going to ls the etc directory and search for carp this time. We have 10, 100, 20, 30, and 40. And is that all the VLANs we needed? So we have 1, 2, 3, 4, 5, and we have 1, 2, 3, 4, 5. That's all the VLANs we needed. So the last thing we want to do is edit the etc sysctl.conf file. We want to make two changes here. First one is we want to do net.init.ip.forwarding equals 1. And this enables IP forwarding or routing for IPv4 packets. All right. So, and then we're going to also enable net init carp preempt equals 1. What this means is there's two states in carp. You have master and you have backup. If the backup assumes the master role because that the firewall went down, that was the master, when it comes back up and gets repaired, this firewall with preempt on here will take back over the carp role regardless. Okay? And that's what we want to have happen. And not only because this could be maybe a better firewall, but because it could be also where we want the traffic to be sent in the network. Things of that nature as well. Because this could also be connected to a different WAN as well. So we have all those interfaces, and we'll verify one more time before we try to bring them up. Got all that, and we got all the carps. So to bring them up, we're going to do sh. For those changes as well, let's do sysctl. And you can put them in without restarting your firewalls. All right, and the other one was carp preempt. So that sets both of those. So back to the interfaces, sh, etc, net start. And, this will tell you if there is errors because it won't be able to, create the interfaces. And right there, bad value. Okay, so it's all right. What we're going to do is, for the ones it said, let's actually, let's grab VNet ID. Out of the VLAN files and see where we messed up. I'll go ahead and pause the video here. Okay, this is why I told you to make sure to put the broadcast address in. Because you get weird errors. It parses it in a certain way, and you get errors if you don't do it correctly. So we missed that in VLAN 10. VLAN, let's see, 10, 140. So let's go back in there and just quick put the broadcast back in. 10, 10. And when you get going on there, sometimes it's an error, that's pretty common. All right, I think the last one was 30 had it, so let's see. I'll go ahead and do that again. Okay, 100 was the last one that didn't have that there. Okay. Okay, you do got to make sure that you have those there. 10, 10, 100, 255. There you go. All right, now let's try that again. So the same command to start the interfaces. And hopefully this time it works. So we're going to verify them again. What you want to verify is VNet ID. Make sure the number is correct there for the 802.1q. Make sure the parent interface is correct, and it is, EM0. It's active, and the IP is 10.10.2, and then that is a hexadecimal representation of a /24 mask. Good, so that's all right. And that VLAN's okay. 30 is all right. 40 is all right. And 100 is all right. Okay, the CARP interfaces as well. To check those, they're CARP and then whatever number we put. You want to check the virtual IP and mask, the VHID, the CARP dev, which is in the correct VLAN here, and the state. So it is master in this case. Now, right away, we can go into VLAN 10 with TCP dump, and those are the advertisements flowing. So that is working. We can look even at every VLAN real quick. You want to make sure you see the CARP advertisements. Otherwise, the FHRP will not work on that network. All right? Good. Good. That verifies not only that the CARP interfaces are correct, but also that the VLAN interfaces are correct. All right. So I will see you on the next firewall in 1 second. All right, now we're on firewall 2 there. And the same stuff is basically going to apply. We want to split EM0 up there. So we want to do up. And actually, let's jump back to firewall 1 there. EM1, we have to put the WAN in. So on firewall 1, WAN. Let's go ahead and put the WAN of 203.14.14.2 with a /30 mask. And we want to add an exclamation point route and add a default route for 203.14.14.1. So don't forget the WAN on there as well, and then you can restart the interfaces. And then you can just go ahead and quick check that once it loads. All right, good. So don't forget the WAN in there. But there we did the same thing with EM0. We want to bring that interface up. So now we're going to go into those VLANs. So again, we're going to start with the external interface, the DMZ, 10, 10, 10, 3 in this case, with a /24. And as you saw before, don't forget the broadcast address. Otherwise, it won't know what VLAN is, VNet ID is. So VLAN dev, and then we want to do... I'm sorry, not VLAN dev. I'm thinking the other. Parent EM0. Okay. And then for this other one, the same thing. 20.3 /24. VNet ID of 20. Parent of EM0. And go ahead and save that. And for 30, 10, 10, 30.3. And then a /24. And then we want to do 10, 10, 30, 255. VNet ID 30. And then we want to do parent EM0. 40. /24 and 4255, VNet ID of 40, parents VM0, and then we want to do one more, so 100, 1010, 100, 3, /24 with a VNet ID of 100, and a parents of EM0. Alright, so that's all the VLANs, and then you want to ls the etc directory again, and just look for those VLANs. 1, 2, 4, 5, and then we can also just cat those files. VLAN, .VLAN star there. And just make sure everything is there. And again, I missed one, so VLAN 100 there. You don't want to miss the broadcast. So you want to go in there, and there, 10, 10, 100, 255. All right. We'll up arrow on that command, and double check there. All right. Now we're going to go into the carp interfaces. So carp 10. Now do pay attention on this one because there's something different that we're going to do on this carp interface. So the same VHID and the same password. But we want to do advertised skew. So ADV skew, and this slows down how fast this carp instance will send advertisements. And the slower they send, the less preferred they are. So if we do ADV skew 100, it's going to slow those advertisements down. So that's good because it means firewall 2 will be the backup. So carp dev VLAN 10 on that. So now we're going to do 20. Do remember, though, you want this one to be the VIP IP from the diagram. So that's what you want there. You want this to be the VIP. Also, make sure the password is the same here and that you have carp dev correct there. Always verify. Because the second you don't verify, you're going to have an issue happen and you're not going to know where you went wrong. But if you verify as you go, even though it takes more time and isn't as exciting, it helps you catch problems. Like that one I almost made there. So then carp dev VLAN 30. Okay, and 40. And if you wanted to do this with IPv6, as some of you may be wondering, you just do init 6 on this. The VLAN configuration wouldn't change at all. And there's another error. So 1010 there. So VHID 40. Make sure the password matches there, and ADV skew 100 and carp dev VLAN 40. Okay, one more VLAN here and 100. All right, VHID of 100, and we want to do password test, and then advertised skew 100, carp dev VLAN 100. Okay, now we're going to cat those files. Do make sure VHID matches that IP, the mask and the broadcast are correct, the password is correct, advertised skew is there, and the carp dev is correct. Now we're going to do sh etc net start, and we want to bring those interfaces all up. All right, it's a good way to verify that you didn't miss an interface, as I know I did. I missed the WAN again. So we're going to go in there again, EM1, and then we want to add from the FW2 WAN on the diagram, 203, 15, 15.2, with a /30 mask. And then always remember, when you're doing static, and you're not using a routing protocol, you have to add the default route. So you want to add route add default, and there you go. Now we can rerun this command again. And there you go, EM1. All right, now let's go through each interface, VLAN 10, make sure that is correct. It is correct. 20, 30, 40, and 100. Good. Now we're going to go through each corrupt interface, and you also notice it's back up already, as it should be, because of the advertised skew. Good. Now the last verification is looking at the VLAN interfaces, and what we should see is the advertisements from firewall 1 going to firewall 2. Alright, you shouldn't see the advertisements for firewall 2, 40, there we go, and 100. Good. Alright, now what we're going to do is add those variables in there under sysctlconf. And then we want to add the ones for IP routing. And we don't want to add the preempt one on this one, just the one for IP routing. Alright. Now to test the failover, and we'll just do it for one VLAN for now. It will work for every VLAN. Let's do VLAN 10. So carp 10. Well, let's just say VLAN 10 down. Or you could do either. Basically, if we look now at carp 10, we're the master for carp 10. But if we look at 20, we're the master for that as well. So if we look there at VLAN 10, now we see advertisements coming from this machine. So that's what you want to see, though. If we bring VLAN 10 back up, the preempt should allow firewall 1 to take back over. So now we want to back up on that and back up on that as well. And now if we look, now we're seeing advertisements from firewall 1 again. And in that process, the client still got to their gateway and got through their firewall. All right, so that's firewall 1 and 2 done, and I will see you in the next section. All right, welcome back. So now we're down here on firewall 3, and we've already configured the VLANs and the FHRP for firewall 1 and 2. So everyone else in all the LANs has connectivity, as far as we're getting, prepared for them. So on firewall 3, we have our interfaces EM0 and EM1. Now EM1 is going to go up toward firewall 1, whereas EM0 is going to go down into the DMZ. So let's start on EM1. And we want to make the IP configuration. So we want to do the DMZ external of 10.10, let's see, 254 with a /24 in there. And we want to add a route. We want to add that as a default route for 10.10.10.1. And it's 1 because the FHRP will function if firewall 1 goes down, and then this firewall will still get out to the internet. But that's what we need for the configuration there. The reason we're not using 802.1q on this interface is these switches have trunk ports, and they will tag that frame correctly. Now we're going to go to EM0. And then we're going to set 10.10.5.1 on here with a /24 mask. Okay, and that'll be the subnet all the servers are in. Now we're going to do sysctl.conf. And we're going to put the IP forwarding. We're going to set that to 1. And we can also, again, set that to 1 without rebooting. All right, there you go. So then we'll bring the interfaces up. And real quick, here's the thing with redundancy as well. We could have had another firewall in here with CARP again, but then you run into where does it end with redundancy as far as power, as far as, routing protocols and things like that, and, paths and everything. So it is a cat and mouse game with redundancy. So that is why we didn't do the other firewall in there. So 10.10.5.1, good, and EM1 has its interface and its address. You can also check the routing table if you want on all of these firewalls, and just make sure all the routes are there how they should be. Alright, that's firewall 3. In the next section, we're going to go through firewall 1, 2, and 3 and talk about the actual PF firewall configuration. So I will see you in that section. Alright, welcome back. So in this part, we're going through firewall 1, 2, and 3, and we're going to add the PF firewalling. So this allows us to restrict what networks can talk to, the others. Now the first thing I just want to mention, if we do ifconfig carp40, and we go down to firewall 2 and do the same, you can imagine my surprise when I was testing things after filming that, and found out that they're both master, and I'm like, wonder why. So what I did was I looked in there and just looked for the carp. I catted the files actually, like this. And so pass is all right on there. So I'm like, well, what's the problem? Well, it was actually on the other firewall. So if you do this again here, you see the problem? On carp40, I forgot the password. So if you forget the password, they won't pair with each other, and they will both become master. And that's not, for load balancing or anything. That's just because they're not functioning correctly. So on this instance, let's put pass test there. And restart those interfaces. And things should look a little bit better after that. Okay, now with those interfaces restarted, we can see that carp40 here has the master status, and carp40 over here now has the backup status. So that's important to realize. Even though they both look like they're working and have master status, that doesn't mean they've peered together and heard each other's announcements and, decided who manages that IP or who load balances with it. So keep that in mind. But anyway, now let's go on to the PF. Alright, so for the PF configuration, we're going to vi etc pfconf, and in your case, if it's already there, just delete the file or rename it. Okay, so what I do first here is we're going to make macros that reflect each interface on the firewall. So what you want to do for that is we're going to let's start with DMZ external. So DMZ ext equals, and then in quotes, put the interface name. Now, if you don't remember, just look at the VLAN ID and that third octet there. So this is, let's see, VLAN 10 for this one. Now we'll do the same thing for the guest. Guest equals. And actually, let's have these be lowercase for today. You can have yours uppercase. It does not affect anything other than making sure you're typing them correctly. So guest here is VLAN 20. And office is 30, and vendor is VLAN 40, which is actually the one we're having trouble with, so you can see how, you can have one little problem that could mess up a lot of things in the network. And 100. Alright, and there is our 5 networks. And you do want to make WAN 1, and that's EM1. And we also want to make the VPT, the VLAN parent. You can name it whatever you want, but you want to make that so the frames get to that interface correctly. Alright, there's our macros done. Now let's do some runtime options. So set skip on LO0, set block -policy drop. We don't want to filter on the loopback here, and we don't want to send replies if we drop traffic. So the first thing I want to do is block drop all. So this blocks, everything going anywhere, regardless of any kind of properties of that traffic. So after that, though, I'm going to start, and I'm going to have a comment above that with a number sign. Do a number sign and do a default deny. All right. Now, in this default deny, I'm going to use block drop quick from the DMZ external network to the guest network. And I'm actually going to go ahead here. Now let's see. Now let's actually test this file at the moment. Okay. That does not need an interface or direction. So what we're going to do is not put an interface on there, and it will apply to all interfaces. Excuse me. So let's go ahead, copy that line. And there's the second, third. All right. And for any more of these here, we want to go ahead and stop the DMZ from talking to the other networks here. So the guest, office, vendor, and management. So that network to those other 4. Copied one too many lines there. All right, and we also want to stop. Let's see. Let's actually make a space here. It'll make it easier for us to see here. And we're going to go ahead and make these other 4. But basically, we want to then start with the next network. So we want to block guest network. Management, we want to block the guest network. The source is different this time. So you want to block guest network going to the other networks. Like so. But obviously not all to the same network. DMZ external. And the office. And you want to block vendor here. So you see though, you want to block the other 4. So we're going to go ahead. Now go ahead and quick pause this. I'll be right back. Alright, I got them all filled in there. And we'll quick go through them. So this first one's just a block for everything, the block drop all. But the quick means as soon as a packet matches the rule, it will be executed on that packet. So anything coming from the DMZ external network going to the other 4 networks is going to be dropped. Same thing for the guest network going to any of the others, the office, and the vendor. We didn't put the management segment in there because we're actually going to open a new line above that comment. And I actually want to pass the, not the T there, pass the management network. So I want to pass the management network to any and keep state on that. So by saying pass quick, it'll pass the management network as we were expecting. So pass in, let's actually say just like that there, pass quick from the management network to any. Since we may want to use SNMP and other protocols like that, or just scan the network, things of that nature, to any of those networks. So that's our default, where we're trying to, not trying, but we're restricting flows. This takes into account any spoofing that could happen, things of that nature. So we need to actually do a few things though, because we need to let traffic through. So we do, under all of those, we want to pass in on the Office interface and from its respective network to any, but you will see why it's important in a second, because it's not going to those networks. So it's like a funnel. It's filtering down. If it matches those rules, it'll be denied, and it will never get here. Because if it did, and we didn't put quick there, it would actually be able to go to the other destinations we're trying to stop from happening. But we want to pass that in on that interface, and then you want to pass that out on WAN 1. And of course, we want to change that source to the WAN 1 address. Like so. And again, as you go, a good thing to do is save the file and run pfctl-nf and then the file name and make sure there's no errors with a file this big and policies like this. You want to do that, because you don't want to get through typing every line and find out you have errors in there. So we're passing the Office traffic in and out on the WAN. And because of the funnel effect we have created, there's no other traffic. There's no other place that traffic can go anyway. Now, let's just do :Y2 to yank these two lines and do those two there. 3, 4. So that way we have the rest of our setup for the other networks. So go in and spread these out a little bit, and then we'll go back over here, and then we'll say, for instance, DMZ external from its network. Let that out. But you just want to change the source network over here in that rule. And then same thing here. And we'll say guest from the guest network. And let's say vendor next. Of course, from management. And of course, you may have a question at this point, now that I'm using this, because we put the rule above. Well, the reason is that rule doesn't NAT the traffic, so management would never be NATed if we didn't add this rule. Even though it would be actually allowed to go out WAN 1, because we didn't specify an interface. All right. So that is our main passing it in and allowing it out. This takes care of anything that those networks would need to do with these firewalls, at least with firewall 1 and 2, because we're actually just going to copy this file over, and then I'll show you that once I get that done. But yeah, basically, that's our main setup. You can add, let's add one more thing. We want to pass quick carp. Well, let's just do pass carp. We don't need quick on that necessarily. We'll just do pass carp. And we want to pass on that VPT interface. Oops, there's a way to check. Give a direction there. So pass in on. Okay. Oh, check again, huh? There you go. Okay, do remember to put pass protocarp on there, like so, and pass on the VLAN parent interface. And again, if you have more interfaces, use more macros and create more rules for them. But as we're doing here, we're allowing the management to go anywhere in any interface, passing the CARP protocol for the FHRP and the failover, and passing frames in on VPT. So then we want to block everything regardless first, but then we're getting our magnifying glass out and making more of a funnel and stopping those networks from talking to any others. And then after that, if they're not going where they shouldn't and they get kind of, think of the end of a funnel where it's getting very narrow, this is that narrow part, where then we're allowing it out to the WAN and natting the traffic. All right, we're going to go ahead with our PF file and copy that over with SCP. So SCP at cpfconf to the user TTEC at 10.10.103. Do make sure it's not .1 because the FHRP will not work that way. Make sure to put a colon in there /TTEC. And go ahead and put the password in. And once that's copied over, we'll come over to that firewall and go into where we copied the file and then copy that into Etsy. And now we'll double check the file. All good. Before we load it, I did make some additions. You do want to make sure you're passing quick on these last 3 rules, the 3 rules here. You want to pass any address on the firewall itself as a source. You want to let that go to any destination. And remember to pass quick. And then you also want to quickly pass the CARP protocol as well as any packets coming in on that parent interface for the VLANs. But that's the same in both files. And then you can just go ahead and load those files on both firewalls. And of course, if you want to, you can go through those CARP interfaces. It's very important to make sure the right ones are master. And I believe that is good. And if you do want to check, if you just do pfctl-e, it will tell you if it's already enabled or not. Or pfctl-si, it doesn't really matter. And let's go ahead and check those again. So 10, 20, 30. Now the reason is the firewall can block CARP traffic. That's why I need to double check this and make sure I'm not blocking something I wasn't intending. And it doesn't matter. It doesn't have to be OpenBSD NPF. This could be, Fortinet firewalls. This could be Cisco, whatever have you. The same concepts apply. You don't want to block traffic that allows something to operate, that is important. But with that, that's firewall 1 and 2. We've gotten the PF configuration done. In the next part, we're going to go to firewall 3, and that PF configuration will actually go a lot quicker. I will see you there. Alright, so now on firewall 3, remember this is the firewall, the separate one that's protecting the DMZ further. What we want to do is we have EM0. Already configured that, and that's the internal interface, and EM1. And that's the external to the rest of the enterprise. So what we want to do is go into our file. And this one will actually be fairly simple. We're going to make a DMZ external macro. And that macro, the interface is EM1. And then we'll make an internal. That internal is EM0. We're going to do those same runtime options. Okay. And the first thing we want is block drop all. And then we're going to pass in on that internal interface from that network to any, and then keep state. And then we want to pass out from that, pass out on the DMZ external network from the internal network and NAT that traffic. Now, is double NAT a good thing or a bad thing? Well, it's not the best thing, but in this case, we're adding more security. And there's actually a very important reason to NAT the traffic. Remember, in networking with routing, you have connected routes, and you have routes that can be put in statically and dynamically. Well, the reason you do static and dynamic is to tell a router about networks it's not attached to. So the reason is, the network that is DMZ internal on Firewall 3 is only directly attached to Firewall 3. Firewall 1 and 2 don't know about that network. The only way they would know is if they have a static route for that network configured, or if Firewall 3, 1, 2, and 3 rather, all ran a routing protocol like OSPF or something similar. But with using the NAT, we're actually taking the internal network and changing the source. So when it goes to firewalls 1 and 2, it is on their, it's coming from their same connected network. So they know how to route a packet back to that network because they have a connected route for it. But anyway, the rest of this config here, we have those two. We're blocking everything, passing it in, and then having the rest of it come out. And we'll do pass quick from self to any. Alright, and we do want to check the file, and then we're going to go ahead and load the file. Alright, and that's all we need for our configuration. All traffic coming from the inside interface will be changed and coming from that source address. So with that, that is our PF configuration done on all 3 firewalls. We'll see you in the next section. Alright, welcome back. So we're in the DMZ now, and we're on the web server. So the first thing we're going to do is we have to then assign the IP and the gateway information. So we're going to vi etc network excuse me, etc network interfaces. And what I want to put in here is just that specific information. So I want to put address 10.10.10.5.251 with a CIDR of /24. And I want to put the gateway for the DMZ firewall, and that's 5.1. Alright. So we're going to go ahead and hold Shift and tap Z twice and save the file. Then do if down enp0s3 and if up. If it's not configured yet, you'll see that. Okay, we want to check with ipadder or ifconfig if you install NetTools that that address is on there, and it is. And now let's do IP route real quick. And the default route is assigned. So before we go pinging and testing the connectivity, let's go into etcresolve.conf and make sure our name servers are set. Now you can set this to external ones, and you can also set this to our internal DNS server we're going to set up later. It doesn't matter. Alright, so we have that. So what we're going to do is go up to the firewall. And remember EM0. This is the interface for the inside of the DMZ. I'm going to go ahead and run TCP dump on that interface and look for ICMP traffic. And what I want to do is send a ping up to 10.10.5.1. Alright, we sent one ping. Alright, actually, this is a very good example. The reason this is unreachable is this router doesn't have its next hop available. So it can't make the packet go any further in the network. So it's sending back an unreachable to the server. But that's part of the issues you're diagnosing when building something like this. That's why it's important to know what these things mean. Otherwise you wouldn't know, where to start searching to fix an issue like that. So, it's like a tower of cards. If the bottom of it isn't stable, and you pull the card out, well, it's all going to fall down. Same thing with networks. Alright, so we have connectivity though, and we did expect that failure. Alright, now we're going to go ahead and install Apache, so apt-get install Apache. Rather apt-cache search Apache. See here what's going on. Alright, let's do something a little different with that, huh? Wow, okay. So do remember, it's Apache 2. Different systems, different package names, all of that. So we're going to install that. But once that's installed, we're not going to focus too much on customizing the website, changing things like vhost inside of Apache or anything like that. What I want to focus on is how we stand up a web server in the DMZ and how we prep the firewall to allow traffic into it. So that's what we're focusing on, how those two go hand in hand. And I mean, believe me, there's a lot more with web servers, and there is a lot more with email servers that, we could cover, but there's just so much when you're doing something of, this size that, that there's only so much you can do. So let's pause this. It's taking longer than I expected. Okay, now that it's installed, and actually, one sec. Alright, so Apache's installed, and let's make sure we can ping Firewall 3. Alright, so now I believe it's on Debian at least, var www. Okay, yes, so var www html index.html. And we'll just up arrow that. And let's just remove that file. And basically just tell anybody that visits this website that, just tell them, welcome to the DMZ web server. Alright. So, in that way, we have the web server somewhat customized. Alright, we'll do service Apache 2 restart. And check the status. Alright, and also you want to check that it is, in fact, listening. Which, of course, for some reason, SSS does not do what you expect. Well, alright, it is listening. So we installed the Apache web server, and we went ahead, changed it up a little bit. So the next part of that, though, since it's listening on port 80, we want to go to Firewall 3 here, and we want to go into our pfconf file. We're just going to make a new macro for DMZ web. We're going to put the IP in here, 192.10.10.5.251. Alright. What we want to do with that is pass traffic in on our DMZ external. And you want it to be TCP from any to any. And then we want to redirect that traffic. And then we want to redirect the traffic to DMZ web on port 80. And that gets us on the first side of the firewall, but after that, you want to pass that out on the internal from the same protocol from any to DMZ web on port 80. And the reason is the destination, because with a port forward, it's basically destination NAT. You're changing the place the packet's going, so it'll be going to that address on the inside of the DMZ. You will do the same thing basically for the email and, DNS, things of that nature. But I just want to show you that when you're building a network, you can't just focus on just the server or just the network infrastructure because it all goes together. The servers won't be able to be accessed in this scenario if we don't have the firewall set up correct. And now, yeah, there's lots of different ways to make a DMZ too, but we won't go into all of that. I mean, we could also have this where there's no firewalls in front of the server, but that's another way. There's lots of ways. So we'll go ahead, test the file real quick, and then we'll move on to the email. So we'll flush everything and reload. Whoops. Alright. Alright, that's what we want to see. Alright, I'll see you on the email server. Oh, and also, if it helps, if you want to see like what we're actually working on. So basically now, we're all the way in here, and we're working on S1. So you notice how the traffic will flow. Just in case you had forgotten what the network would look like. Alright, so I'll see you in the next one. Alright, now we are on the mail server. So the first thing we're going to do again is set up the addressing information. So again, we're going to go down here, set this to static, and put our address in 10.10.5.252/24 with the gateway 10.10.5.1. To make sure in etc resolve that you have DNS servers. Then at this point, we're going to go up. Whoops. Let's bring the interface up. Verify that the address is there. Good. And then do an IP route to verify our default route is there. And it is. So again, we're going to go ahead. We're going to run TCP dump here on EM0. And then if we ping that gateway, we have connectivity to the gateway. Alright. Now, the reason I don't have connectivity out to the internet is in the situation I have with virtualization, it's not feasible for me to run the switches and everything on, one laptop. So that's why I don't have full connectivity, but the concept is completely the same. So, we have connectivity there. So remember how we went into the firewall? Let's just do that right now. And put in DMZ mail. And get the IP put in. So 252. Wait, did I put 252? So for, let's actually enter down a couple times. For the mail, there's actually a few things we need for that. Basically, we need, when we redirect it anyway, we want to redirect to the mail, and we want to redirect port 25. And then when we do that, you want it to come in again to that same port. From any to any. Whoops. From any to the DMZ mail. But you also may want additional ports. So let's actually just do this. Let's copy. So, for example, in some scenarios, for the other two ports, you might want, for instance, IMAP S, because you may want, obviously, your users to access their mailboxes and download their messages. So, that allows that. And some mail clients need to use submission or, SMTPS. So that'd be 465 if you want to use the submission port 587. So just examples of how the network helps the email servers and everything operate. So let's check that file and flush it. So that's the network part, though. We are ready to go as far as that goes. And the fact is how we're using the macros for that. So now we do need to download iRedMail, the script for it, because iRedMail is a framework that sets up the SMTP, sets up the IMAP, sets up at least one part of like DCAM and things of that nature. But okay, I'm going to pause the video, get that URL. I'll be right back. Alright, so I made sure WebGit was installed first, and then I went ahead with WebGit there and downloaded it from GitHub. So after we've done this, and don't think you have to use this software, as I have said throughout this, this is just a guideline of how you would do something like this. And, you could substitute this with Exchange, take your pick. There's many ways to do it. So we're going to untar this with tar xf and the archive name. Uh-oh, we're really overloaded at the moment. So as I was saying, tar xf and then the name of the archive. And once that is unpacked, cd into that directory. And you want to run the iRedMail script. So you want to run bash iRedMail.sh. So with this error, and believe me, I bumped my head on this lots of times administering mail servers, but what you want to do is go into the etc hosts file and let's see here, webexample.com. You do want to set this, and I don't remember if it was on Debian that did this. I think it is, where you want to set this to something else. Alright, so just make sure it is a fully qualified domain name in that file. And now we've kicked off the script. And basically it's going to install all the parts of a mail server for us. But I'm going to try to explain the important options to you, so you understand more what's going on. Because here's the thing. With mail servers, once you understand the basics of SMTP, of IMAP, of where your vmail directories are on a mail server, and how to manage like your IMAP configuration and things. Once you've done that, you can pretty much transfer those skills over to any server solution. We'll go ahead and pause this real quick. I'll be back when it gets to the questions. Alright, so now we're at the dialog here, and what we want to do is say alright, so the first thing here, this is where when users on the system get mail, where it's stored. And basically, here's the thing I want you to understand. A lot of the times with email servers, small and medium-sized ones, for each user that receives mail, they don't have a shell account. So in other words, you can't, for instance, SSH into that account on a Linux machine. It is a virtual user that's tied to a directory on the file system. So what we're specifying here is for the domain where we want to put mail messages that are coming to that domain. So the mail server then puts them there and can send them over IMAP to our mail clients. So var vmail is okay, and that's perfectly fine for our purposes. And at least for iRead mail, you do want the web server, because then you can get into the admin interface for adding domain names, adding mail accounts, and things like that, specifying quotas. Now, I choose MariaDB simply because I have the most experience with MySQL with this stuff. So just hit spacebar and enter there. Now, you do want a password for this. We're just going to put test here for the database. Use a more secure password in production. So here we're going to put test.com. Again, if you're following along, don't expose something like what I'm showing you to the internet, because, well, you don't just throw domains like this up on the internet. So then you want to put in your password for your mail administrator. And then these in this product are fine to leave blank. And the webmail is actually really nice if you don't want to use something like Thunderbird or Outlook for this. So we're going to hit next on this. And double check our configuration and say yes, that we want to continue. And basically, with the answers we gave it, it takes those and installs all the packages needed and sets them up. So otherwise, and I've done this, you go into files like your etc master.cf and postfix, things of that nature, your SMTP servers, and you configure all of the configuration lines for the software. And that is a big job. There's a lot of complexity there. And there's also lots of opportunities to kind of mess things up. So, but that's the best way to learn, though, is actually go and look at postfix and actually figure out what each line in the config does and build your own. This is somebody that knows all the intricacies of IMAP servers and SMTP servers, and they've put this together for us to help administrators, so we don't have to think about every little piece of each service. But anyway, so with that, this will install, and then we'll be ready to go. We'll see you in 1 second. Alright, one of the final questions it asks is if you want to allow port 22 in your firewall. Now, you can say yes, you can say no. In this case, I will say no in this case. I had an error before with this because it won't open that port in NF tables, but I believe the issue is actually because we don't have NF tables, but that's besides the point. So the mail server is fully configured. All we have to do now is reboot, and then you would go into the interface. You can set up more domains to serve mail for, and you can set up more users and other parameters for those users. But with that, I will see you on the next server. Alright, so now we're on our DNS server, and this is the DNS server in the DMZ. So I do want to say before we get into this, so no one is confused, this is a public, this is a public accessible DMZ, a public accessible DNS server inside of the DMZ. We could have this for the office segment. They could have their own dedicated DNS server in that segment, or we could also, if the network was small enough, put the DNS server inside of the firewall as well. Alright, so that basically applies to lots of what we're configuring here. They don't just have to be in the DMZ. They can be in any of the segments, or they could be put on the firewall. With that out of the way, though, I've already logged in to the DNS server, and we have Firewall 3 up there, as we've had. And the first thing we're going to do is vi etc network interfaces, and I need to set up those IP addresses because, without the IP, we can't get into, any of our, get anywhere in the network. So let's see, 10, not a J, I don't think that's an IP, 10.10, 5.253, and that's a /24 CIDR, alright. And do remember you get the CIDR right, because otherwise it doesn't know what network it's on, and it won't know how to route. So 10.10.5.1 is the gateway. Alright, let's go into etc resolve conf. Make sure our name servers are correct. And this can also be internal ones. Maybe another section of internal DNS servers. So then we're going to go ahead and do if down enp0 s3. Oh, what did I miss here? Oh, it helps to put the keyword in. So if down and if up. And we'll double check that with IP adder. Make sure we have our default route and the connected. Alright, and now we'll ping firewall firewall 3 up here. Good. Okay. So, what we'll do first on this is, before we do anything else, because, as I've said, it all goes together and we can't ignore at this point the network infrastructure. So, we got to put the stuff in the firewall here for the DNS server, so 253 for that macro. And at this point, these two lines should do it here. We'll go ahead, copy these two, paste them, and we're going to pass that traffic in, but instead of obviously being DMZ mail, we want this one to be DMZ DNS. And for now, just port 53. And of course, pass that out to port 53. And DNS. Did I put DNZ there? Yes, I did. Alright. So that's passing it in, redirecting it at layer 3 to the DNS server and that port number as well. So let's check that. Good. And load that in. Alright, and with that out of the way, we have our port forwards in there. So let's, the next part is we have to get it, the Unbound installed. So to do that, we're going to do apt get update. And, to make sure we have the most up-to-date repositories. And with all the virtualization, it's a little bit slow, so I may have to pause this. Not sure. Yeah, we'll go ahead and pause it for a second. Alright, now we're going to do apt get install Unbound. And just say yes to that question. And once this is installed, then we'll go ahead and start our configuration. It'll be pretty interesting configuration since we're going to be setting up DNS records for our servers. So that will be very cool. And again, I'm going to pause this real quick. Alright, now that it's installed, let's go into etc unbound. And we want to remove unbound.conf. In the .orig and the .prod, you're not going to have those in yours. I was testing things before filming. So now we're going to vi unbound.conf. You can use nano as well. And what we're going to do is a real quick configuration, server clause, and we're going to do all interfaces. Okay, and then we're going to do an access control entry. And we want to have the networks on there we were using before. We'll start with the DMZ. So 50/24, we want to allow that. But to save time, I'm going to copy the line here. And I'm going to so that's our first network. So that's the second, third, fourth, and fifth. And for these networks, what we want to do is just, we had the one for VLAN 10, remember, the one for 20, 30, 40, and there was one more there. We'll just quick. The last one was 100, and we want to allow that. Now we also want to allow the loopback interface. And we want to allow the IPv6 loopback address. Make sure to put a 1 on there, otherwise you will be, just make sure to put ::1, otherwise you get an error. So we want to allow that. In the last two lines, we want to deny some networks. We want to deny the rest of any IPv4 networks. And we want to deny any other IPv6 networks other than the IPv6 loopback. And if you have IPv6 networks, just put them in there, with the, appropriate prefix length and everything. So with that done, we are going to save time, let's start with the other information for the local zone. So local zone, and then we're going to put example.com. But you want to put a dot after that, like so. And we want to put local data. And here we're going to start putting web.example.com. And that is an A record. It's an internet type. And its address is 10.10.5. Let's see, do I remember? It was, I think, 251. Yep, 5.251. All right, let's go ahead and just copy that line because it will save a lot of typing. So we had 1, 2, 4 servers. And all we should have to change is the DNS, the record part right here. There's the IP there. Yeah, actually, that one is the mail server, mail.example.com, and then its address and DNS. And the last one is dhcp. All right. So that is our local zone for example.com. And under that, we're going to put a forward zone, and this is for answering queries and everything. So name colon, and we want a dot there. And forward adder, we're going to use just public DNS servers. And we do want a forward first. All right, now we're going to do unbound check conf. Okay, perfect example. We made an error there. I actually forgot to specify the type, I believe. At local zone, after that, you want to put static in there as well. Local zone failed. Alright, I'm going to pause it for a sec. Once I fix the errors, I will explain to you what had happened. Okay, are you ready? This is what I got wrong. It was, I reversed the IN record. Make sure to put, it should be IN and then this record. So I'll pause this, we'll reverse those, and then we'll move on. All right, we got them reversed there. So this is what it should look like for you. We have all of our networks that we need to access this DNS server allowed. And, you know, as I said, that may change where you put the server and what networks you want to have access to the server. We can restrict access not just by our firewall filtering, but also these access control entries are an example of server-based access control. So even in the individual server program, even if a firewall didn't block these networks, the server still could refuse to send a reply to them. So there is security and all of that on many different levels in a network. So that's what we have going on, though. And as I said, you can put this in many different parts of the network. It could go in the office, on the firewalls, etc. It could even be bind. It could be a Windows server running, you know, their DNS. It can be many different things. So with that, though, we'll go ahead here and verify those names and make sure the DNS records are working correct. All right, so we are on our DNS server right now, and what we're going to do to test this is do dig at, and we're actually going to look up on our loopback. So in other words, the request will go through our local TCP IP stack and get to the DNS server. We're going to test just google.com first to make sure the forward is working, and it is. Now, I do want to reiterate, don't use example.com. That is a live domain, so if you're connected to the internet testing this and you have forward first set to yes, it will go out and get the answer from a root name server, not Unbound's local data. It's a local zone file. So what we'll do is now test for that web.example.com, and that's 10.10.5.251 as we expected, and look for mail. We got that. DNS, good, and dhcp, good. Now, some of these as well could be resolved to public IP addresses on the internet for clients coming into the network. So this is what's called split DNS. Any client inside of the network will get this internal IP address as an answer instead of the public IP everyone else would get. But as I said, you can move these servers around, you know, like building blocks into whatever segment you need. But with that, we're going to move on to the next server, so I will see you there. Alright, now we're on the last server, our dhcp server. And before we get started, I'm going to say again, you can put this in its own segment. You could have a dhcp server for just the office. You could have a dhcp server just for the guest, etc. But you could also have the dhcp service, secondly, on the firewalls themselves. And also, we could have the DHCP server in one segment and have a DHCP relay agent that turns the discover message into a unicast. So other broadcast domains, other networks can get a lease from the DHCP server, even though it's in another network, separate from them. But there's many ways to do this. What I want you to focus on is the fact we're setting up a DHCP server. Not really the configuration, not really where I'm placing it. I want you to see the building blocks of how we go about building a network like this. So what we'll do is first go into Etsy network interfaces, and let's put our IP addresses on here. So we're going to do, that's not how you spell static. We're going to do static. We'll put our address in here, 10.10.5.254/24. We'll put a gateway in of 10.10.5.1. Alright, do an if down, enp0s3. And an if up, enp0s3. Excuse me. And then we're going to double check that. And double check our route as well. And as always, though, we do want to check to make sure we're getting connectivity. Okay, and again, it's not routing out to the internet yet. That's why you're seeing that message being generated. Let's now go into our firewall here and then do our macro for the DNS server 10.10.5.254. And again, to save time, we're going to go ahead and let's copy these two lines. And here we want to use UDP. And we want to redirect that to be the DHCP server's address on 67. And same thing down here. We're going to do DHCP on 67. Now, as well, I want to mention DNS can use TCP or UDP, but for that, what I actually meant to put was UDP. All right, there you go. So that's what we need for our DHCP server. Okay, that's the network part of it done. Now let's go in and start the configuration. So the first thing we want to do is we want to do apt-get update real quick. And I don't know if I'll pause it this time. I think it'll be over quite quickly. Almost. Alright, now we'll do apt-get install ISC DHCP server. And again, this could be Windows Server running DHCP. This could be the newer Kia DHCP server that's out. The important part is to focus on the fact the DHCP service is an important part of a network. That's what I'm trying to get across. So once this is done, we'll just go in and set up our scopes for all those networks, and then we should be good. Alright, so you will notice this error when it first installs. It'll try to start. The reason is there's no interfaces with the IPs in there that we're trying to have as scopes. So there's no interfaces this can listen on, basically. All we have to do, though, is go into etc dhcp, and we want to remove, well, you can do this as well. Let's go ahead and just copy that file to an original, like that, just to make sure if we make a mistake we can go back. So let's remove that file, though, the .conf file, make a new one, and we'll do option domain name, and it's safe to put example.com because that is what our DNS server is serving in the network. And now option domain name servers, and we want for that for 221 some comma and 4222. I'm sorry, not 4, not two external ones, so I apologize. And then again, even if this was in the office, we want to put on there 5254. Whoops, 253. But you see, if it's together, that would be the DNS server that clients are going to. And now we're going to put subnet 1010. We'll start with the VLAN 10, and with the net mask of a /24. And we'll go ahead and have an opening curly brace. And we're going to do a basic range of just 2, well, let's do 110 there, through 200. And then do an option routers. Now, what gateway address do you think we're going to put? You got it? Well, if you think 10.1, you got it. Because remember, this all connects together with the network infrastructure. Because if we don't put that, our FHRP isn't going to work. And if that doesn't work, we're losing some of our redundancy there. But that's what we put there. And then you want to end that with another brace there. And let's see, we have 1, 2, 4, 5 lines. We'll go ahead and open a few lines below that. Copy these 5 lines. And that was 1 network, so 2, 3, 4, 5. Okay, and now we're going to do 20. And to keep things simple, we'll just change the third octet in these, okay? So now that one, 10, 10, 20, 0 with a /24. 20. And then we had 30. And 40. And the last one was 100. So 10, 10, 100, 100 through 10, 10, 100, 200. And don't forget the gateway, because that gateway has to be on the same segment, because the client has to use either ARP and IPv4 or Neighbor Discovery Protocol and IPv6 to find the MAC of its gateway. So 40.1, 100.1. We just want to make sure all these are correct, and they seem to be. And now we'll do dhcpd. I believe it's -t on this one. Yes. All right. So now if we do the start command, which I've already done, we'll do status, and it is running. Now, if you follow along and you're using Debian, let's take a look at Etsy default ISC DHCP server. Make sure under interfaces v4 that you put the interface you want to listen on, as well as if you want the interfaces network to have DHCP on it, make sure to put a scope for that. But with that though, that's our DHCP server configured. So that is our servers done. All right, so the last thing we need to do here is on our firewall 1 and 2. And what we want to do on these firewalls is how I said about the double NAT situation. We need to bring in any traffic coming into the public IP of these firewalls. We want to NAT that to be going to firewall 3, and then the port forwards there will take care of getting it the rest of the way. Now, like I said, we could have a DMZ in front of all these firewalls on a separate public network. That's fine too. That takes care of NAT, and it makes things simpler. But both ways are valid. So we're just going to quick go into etcpfconf, and let's go ahead. Let's make another macro for DMZ FW3. So 1010. Let's see, what was the IP of that one? Let's see, what was our DMZ external? 10.10.10.254. And what we're going to do is really, we can put it anywhere in the file. That doesn't really matter. We'll put it just at the bottom. And what we're going to say is pass in on WAN 1 from any to any. And then what we're going to say after that is, pass in on WAN 1. You forgot to specify the protocol. So init proto TCP from any to any on port 80, and we want to redirect that traffic to the DMZ firewall 3 on port 80, and we want to keep state. And then we're going to pass out on the interface of VLAN, well, DMZ, on DMZ external. And then the same protocol, oops. Net proto TCP from any, and it's going to DMZ firewall 3 on port 80, and we want to keep state. All right. So now let's copy those two lines, because we want other ones for the rest of the traffic, because we also want to allow some UDP traffic in. And the reason is sometimes you want to run your own in-house DNS server, and this prevents things like spoofing from occurring. So we want that one to be on 53. So in this case, the address is the same, but when we redirect it and pass it out, the port is changing. I'm sorry, the port isn't changing, the layer 3 address is changing. And the last one we want, in our case, is 25. And going to 25 there. Oops, and then we want to pass that out to 25. And there we go. And you could definitely use a VPN for that, to have them come in and get the email through the VPN. But, I mean, there's lots of different ways to do that nowadays. So, with that, basically, we'll save that file and flush and reload it. And then just SCP the pfcomp file over to Firewall 2 like we did in the beginning, and you're all good. So with that, that concludes this series on building an enterprise network. I hope it was helpful, and I hope it was educational for you. I really enjoyed making it for you, and I hope you liked it. Thank you for viewing, and have a very nice day. As always, it's Tyler with T-Tech.